This is the A.E. Staley Sagamore cogeneration facility, which will be capable of supplying 190,000 pounds an hour of steam at 685 psig and 750 degrees Fahrenheit. The plant will be capable of developing at least 7,415 kW at full throttle flow.
Okay, now you see a truck pulling in to unload its load of coal on top of the Grizzly. Now you're seeing the truck being dumped by a hydraulic cylinder.
The boiler is designed to fire all of the specified coals. It is noted, however, that it will be necessary to add a dry scrubber system for future firing of high sulfur coal.
This Grizzly is divided up into openings that's approximately 3 inches wide and 5 inches long.
The truck receiving hopper, located directly below the Grizzly, is designed to receive 40 tons of coal in 2 pyramidal hoppers. At the base of each pyramidal hopper is a vibratory pan feeder, which conveys the coal at 50 tons per hour to a 50 ton per hour single roll Williams crusher. Tramp iron removal is provided for by this magnetic separator. The coal then discharges down to this 50 ton an hour single roll crusher and discharges from the crusher and is loaded into the base of a 50 ton per hour bucket elevator. Here we see the outside of the 2,000 ton storage silo and its bucket elevator. The coal is then conveyed to one of 2 day bins in the plant by the use of this bucket elevator and a transfer screw conveyor. There is also a wet dust suppression system which controls the dust at the pan feeder discharge and around the coal crusher.
Okay, what we have here is a storage bunker for the pulverizers. We have one for each pulverizer that holds approximately 200 tons of coal or a day's supply of coal. The coal discharges out of the bottom of the bunker valve down through this slide gate, which is called the bunker slide gate, travels on down through this conduit and discharges directly on top of the belt located inside this stock gravimetric feeder. This valve has to be open before the equipment will run and deliver coal down the conduit and into the feeder. Once the coal enters the feeder, it travels down the length of it by way of the belt, all the way down to the end of it, where it discharges, drops off the end of the belt, travels down through the bottom into a chute that leads directly into the coal pulverizer.
What we are now looking at as a window at the end of the stock gravimetric feeder, and through it we can see the coal containing upwards to 8% moisture as it discharges directly down into the Williams pulverizer. The new plant is located directly adjacent to the existing boiler house and serves as the primary source for the plant's electrical and steam requirements.
The fan and the feed flowing down the feed chute. This pipe is connected with the discharge of the stock gravimetric feeder. Comes down through this pipe and down into the mill. The noise you're hearing is the coal coming from inside, that's flowing inside the conduit. Okay, the coal then enters the grinding chamber inside the mill where it's then ground up.
Mill bottom discharge permits continuous removal of iron pyrites, slate, and in particular tramp metal, simultaneously with the grinding operation. Some product beneficiation is possible by the removal of the hardest to grind materials that accumulate at the bottom of the semi-fluid bed at the base of the mill. Removal of pyrites and tramp metal and slag producing impurities are possible by periodic dumping as shown here.
We're standing underneath the gearbox now, and as you can see, the mill is in operation. There's absolutely no noise coming from the mill itself. The noise you are hearing is from the gearbox. Okay, our primary air supply for this DF mill enters by way of this insulated duct here. Comes inside the wind box. Circles the entire mill and comes through at inlets throughout the circumference of the mill. The air then sweeps inside the grinding chamber, flows up through, with the material with it, up through to the spinner separator, where the material is classified by the speed of the spinner separator. When the material is small enough, it then leaves the classifier, exits out the top, and flows through a conduit across through the exhauster and then on into the boiler itself.
Coal and air come through this pipe from the pulverizer down up into the exhaust fan. The coal and air then come out of the exhauster past the temperature probe into the splitter valve. The splitter valve distributes the coal to the two pipes above it through the burner safety shutoff valves. The coal is then transported out through these pipes to the burners.
This is the coal inlet pipe. The coal and primary air comes down the pipe and enters the burner in a swirling motion and travels into the furnace. The coal comes in at a 2.3 to 1 air to coal ratio. The air transports the coal and delivers it into the combustion zone where it mixes with secondary air, which comes in from above through a large area called the wind box. The air and coal mixture mixed in the furnace zone. They're ignited by the igniter, which is fed to this igniter tube, with natural gas. At a stable load of approximately 40%, the igniter is taken out of service and the coal is self-sustaining. When the coal is self-sustaining, the excess air to the unit is approximately 4 to 4.5%.
This then is the Foster Wheeler SPEC standard SF type steam generator. The boiler is capable of supplying 190,000 pounds per hour of steam at 685 psig and 750 degrees Fahrenheit, and developing at least 7,415 kilowatts per hour at full throttle flow.